welcome to thedeciphers.org. My name is Cordelia Kataria, and today we are going to solve two Geeks for Geeks problems. One is the 0 to 1 knapsack problem, and the other is longest palindromic subsequence. And how you can participate, viewers, is that you can write something in the chat if you have any idea of how to solve it or something like that, or if you have any questions. So I'm just gonna delete that first. Okay, so then let's start. Okay, so let's start with the 0 to 1 knapsack problem. So you are given weights and values of n items, and you have to put them in a knapsack of capacity W, and to get the maximum total value in the knapsack. Note that we have only one quantity of each item. In other words, given the two integer arrays, val of 0 to n minus 1 and weight of 0 to n minus 1, which represent values and weights associated with n items respectively. Also, given an integer w, which represents knapsack capacity, find out the maximum value subset of val such that the sum of the weights of this subset is smaller than or equal to w. You cannot break an item, either pick the complete item or don't pick it at all. So 0 to 1 property. 0 or 1 property. So one example is where the number is 3, the weight is 4, and values is 1, 2, and 3, and weights are 4, 5, 1. The output is 3, and that's because of 3 and 1. And another example is n is 3, weight is 3, there's 1, 2, 3 and 4, 5, 6. Then the output is 0 because all of these weights, they are above the total weight in knapsack. Now let's begin the working out. Okay, so 0 to 1 knapsack problem. So I think I'm just gonna have a look at the question again. I think what we can do is we can use recursion here because it is either pick the item or don't pick it. So in every step of that recursion, we can do a pick or don't pick statement. So every step, do a say pick or don't pick. Okay, so, and then, so after you do that, just then print, then no, not print, return then return the maximum, because we want to find the maximum value that it can pick, so turn the maximum of those. Okay, so
So you have to keep a track of the weight.
We have to also keep track of the weight we've done so far. So and that will tell us what. And so that will tell us what. And the weight will tell us the maximum amount of weight we can do. So if we can't do any of the so if we can't do any of the if we can't, so we'll know if we can't pick one or not. Then yeah.
Mm-hmm.
And I think we'll also have to keep track of the wait, no we won't, because we're going to return it. I was about to say I think we need to also keep track of the value so far, but I think we're going to keep returning the value, so that's not a problem.
Exactly.
So let's try to do the recursive approach. So let's go to the question. Then I think I'm going to do another function. So maybe nap01. So I have to. Hello. Hello, Cubostop. Hello, Mark. Sorry for the
Cubostop is me. I was saying hi to Mark.
Okay. So then define nap01 of. So we have to keep track of W, and actually I think we should make the function in there. Then we can use the weight array and the value array, and
yeah, we can declare the function locally as well.
Yep. So
that's one good thing about Python.
Yep.
So what variables are we tracking here for the recursive function?
We need to track W, and I think we also need to.
What is W here?
W is the weight. Left in the knapsack. So we're just going to minus the minus the weight of that item in every recursive call where we actually pick it.
Right.
Yeah, so we're going to do keep track of W, and I think there's another one.
So we need to keep a track of the current index as well, like which item we are trying to pick or not pick.
Yeah, also that, because if we don't keep track of that, then we won't know which item we have to pick or don't pick. So
Exactly.
So if I is n, wait no, yeah, I think if I is more than or equals to n, let's just to make sure, then return.
What is it? Okay, and it's given. Okay, no problem.
Wait, if I is n, then let's just do equals. So if I is n, then just return return 0, I think.
Right.
So then so otherwise then just return nap I01 off, and then actually x equals, now put one off, and then this is the pick one off, and so it's w minus weight of I, comma I plus 1, and y.
This is the first option.
And we also have to add on the value of the item.
Right.
So val of I, and y is, that's the don't pick one, so we're not going to minus weight of I. And then
If we are picking, then we also need to make sure that like the weight can actually be picked, or it cannot be picked. So you need to put a condition for that.
So if weight of I is more than, if actually less than or equals to weight, not weight w, then we do the x thing. Actually let's do actually just 0, so then return max of x, y. And then over here just return nap I01 off, and then this w0 I0.
It will be w comma 0, I think.
Yeah.
Like the function call. Capital W.
Yeah, it meant
You just put capital W there, rest all is fine. Yeah.
so, and if we submit, we actually see that the time limit is exceeded. So let's think about what we can prove on. So let's draw the recursion tree from this. So then that might help us gain insight. Okay, so let's do not sure what test case to do. Maybe let's do
What happened?
I'm thinking of a time limit exceeded happened, so I'm thinking of a way to visualize the recursion tree.
Okay.
So,
You need to open the notepad for it.
yeah, I forgot to switch to that. Okay, so we need to do the right. So we have to think of a test case first. So let's do wait.
So let's just look at it like this. Let's say you have a W here, comma 0. This is the initial call, right?
What?
I'm drawing on the notepad.
Right. Yeah, I can see now.
Okay. So the initial call says that we call by W and the 0th bit. Sorry, 0 index, right?
Yeah.
So now you have two options. Either you decline the weight of 0 or you keep the weight same and then call 1.
Yeah.
And at the second level, you have two options 0 minus weight 1.
Yeah. Okay. So
These are the options, right?
yeah. So I think that so there's whenever we see that we can use recursion, and we have to optimize it in some way. It's pretty much always dynamic programming. Actually, it's not pretty much always. It's just in a lot of problems it's that. So, but it looks like that we can't find anything where the variables are the same. But do we really need to keep track of the index in the dynamic programming? I don't think so, because we can do the exact same thing as something with a larger index if we just keep making this branch bigger. So to weight minus weight of 0 come 3, and if we keep going right, then all we need to check is the same is the weight. So
Why won't dynamic programming work here?
It's,
I think dynamic programming is fine here. So if you have, let's say you have these boxes and you have found the answer for this part, for the right part, then you can easily make a decision for these two values. So something like this helps us to identify dynamic programming problems.
so
If you have made a decision for the rest of the array, then we can make a decision on this element, like the current element.
yeah, so then just so then I guess you can add add some dynamic programming. Wait, not here, over here. Doing that.
I need to put the code screen up, I think.
Oh yeah. And then you can.
I taught you a way to put the dynamic programming without passing it as a value.
Oh yeah.
So you can try applying that.
Right, so DP. So if W and if W is in the DP, then
So W and I both are a part of the state, right?
Yes, so W comma I. But I'm pretty sure that I'm pretty sure we can't do the I'm pretty sure we can't do the dynamic programming with the weight and the level and the index, because if it's at the same index, then I'm pretty sure it has to be different. So
Like the weight can be same at a lot of indices, right? If you don't pick something once and then you don't pick it again, then the W will remain the same for all the states.
yeah.
So you need a index variable to know which value you need to pick right now.
Okay. Okay, so then DP of max that is equal to DP of not max of x comma y of so we're going to do W comma I is max of x comma y. Let's make that a bit bigger. Then just I think that should work. Okay, and then yay, it works. Right, then now let's move to the next problem. Longest palindromic subsequence. Right, so given a string, find the longest palindromic subsequence. So that's basically that's a part of the string that's a palindrome, and we have to find the longest of that. So let's move to working out. I'm just going to so then wait one second. Okay, there, that's better. So then longest palindromic subsequence. Okay, so then in the string, so if we want to find the longest palindromic subsequence, then we have to first find what's a palindrome and what's not. So then we can use do a is palindrome function to check for that. Define is palindrome. Define. I'm just gonna make it more like is pal. Make it a bit easier. Then of string so let's just call it S. Then if len of S is 0 or 1, if len of S is 0 or len of S is 1, and it's just, I think we should do that in question bit. So then find of S. Right, so if len of S is 0 or len of S is 1, then just return let's return 1. Always return is pal of return S of 0 is S of -1 and is pal of S of 1 to minus 1. So then, yes, that's the palindrome code. Now let's move to working out.
So there's a very short way of checking if a string is palindrome or not. In Python, you can just write return s equal to s square bracket colon colon minus 1 colon square bracket close.
That just reverses it. So,
Yeah.
So return.
That's a very shorthand way of writing it.
So flip to question 1. So now let's go to work out. Okay, so then we've got a function to check whether it's palindrome. Now we need to find what's the longest palindromic subsequence. So what we could do is just go through the so we could use a sliding window approach, and it would keep going and off size 1 and then check off size 2, then if we do the other way, then it'll be done a little bit faster in the average case. Then if we do the size of the number, then the number minus 1, then minus 2, and what are you writing?
This is a sample test case. So how will you run your algorithm on this?
Then I would first take the entire thing, check if that's a palindrome, then and then if it's not, then check using sliding window to do those two, and then
so you have to get the longest palindromic subsequence.
Yeah, then
Not the substring.
Right, so I don't. What's the difference?
So for this question, the answer will be if we pick let's say we pick this B and this B. We pick this A and this A, we pick this B and this B, and we pick this C. So answer will be B, A, B, C, B, A, B. The length of this is 7. So answer is 7.
Okay, so
The characters are basically not continuous.
okay, so then that means we can skip over characters. Okay, so then what you could do is we could use a recursive approach then, and
Right.
similar to the last question, pick or don't pick. So first it would Cyanic outside. So it's so every step pick or don't pick. Right, so then again. And if we put that up, so you should take so we should think we should take I think what we can do is take the longest link pass, keep track of longest subsequence so far, of the length of that. Keep off. Wait, that's what we're turning, so I don't think we need to keep track of that. And then I think
Let's put a pointer here and a pointer at the end. Let's call this I and let's call this J. What would be the condition if a palindrome were to include these two integers as the ends?
the conditions would be everything in the middle would be would need to be a palindrome.
Yeah. So I and J need to be the I and J need to be the same, and the characters in the middle should be a palindrome as well, right?
Yeah.
So let's say our function is I comma j. If ai equals aj, then our palindrome will be 2 plus, because we have used these two characters, then how can we move our I and j? I'm writing a little below.
Okay. There we go. So I think it's 2 plus f of the I plus 1 comma j minus 1.
Right. And what if these are not equal? What will happen then?
If they're not equal, then I think it just return f of I plus 1 comma j minus 1.
So you have moved both those pointers only in the case when these two, we are picking these two. Right? If these two are not same, then we don't have to eliminate both of these, right? We can eliminate only one right now. So we can do something like f I plus 1 and j. Let us keep the j constant and move the I pointer forward. And what is the second option?
And the other one is move the j pointer but not the I pointer. And
Right.
we don't need to do both because because in the because in the iteration after this one, if they're not the same, then it'll just do j plus 1 anyway, j minus 1 anyway.
Where?
What?
I didn't get you. Can you say that again?
And we don't have to do both because in the iteration after one of them, it will probably do if they're not the same. If they're not the same, then it will do that thing anyway. Both of them anyway.
You need to either move the I pointer or the j pointer, no?
Yeah, that's what I mean. We don't have to like both of them.
Yeah, in the ideal solution, we have to do one of them, but right now we are just trying to find the longest palindrome, right? So we need to do both of them.
Yeah.
So right now we have the option of either moving the I pointer or moving the j pointer. We need to do one of these operations. So this shows that we have moved the I operation, and the other will be I j minus 1, something like this.
Yep. Then that way we can solve the problem. So
Is there any edge case, sir?
if I is if I is more than or equal to j, then just return that length.
And so we are always having two there, right? There would be a case when you don't need to add two.
When I think it's when they're both on the same spot.
Exactly.
So
that is just one of the base cases we'll need to take care about.
Yeah, and we can get to the question. Okay, so you define function of 2 pointers, then if a so if if I is more than or equal to j, I think actually more than j, then return return just the return the length. It's 0. If I is j and a of I is a of j, then
Okay, if I is equal to j, then a of I will be equal to age always.
I
Like they both are the same index, right?
Yep, so then I guess it'll be just then I guess return f of I plus 1 comma j. But then they'll just return.
I is equal to there, j, then like we just return 1 then, right? Because we have a palindrome of 1 then.
Yeah, I guess so then.
Like every character is a palindrome in itself.
Yeah, so then just and if a of I is a of j, then return 2 plus f of I plus 1 comma j minus 1, and otherwise return return the f of I plus 1 comma j, I plus 1 comma j, max of I plus 1 comma j, and I comma j minus 1. And over here just return j f of 0.
Actually, everywhere you should be writing S, like capital S, or just take the initial variable too, like the self comma a. Just put that.
We only changed 2 things, so yeah. So length of
Yeah, this is.
Okay, and yes, it works. If we submit it, time limit exceeded. I think we might have to apply dynamic programming again.
Yep.
And comma dp. Okay, I'm gonna make the text a bit bigger.
Declare the DP globally.
I'm just making the text a bit better so we can so we can see it better. Then dp.
That's good.
So dp is that, and then so if I if I comma j in dp, j is in dp, then return dp of I comma j, and then so So dp of I, j is that, and return dp of I, j. And let's copy that and paste that. And then just
If you're returning dp of ij anyway, so you can just write it out of the if statements. Just a very minor thing.
and we can do it like that. 7 and 7. Yay! 30 out of 30. I think so. Solve the problem. Yeah, we're actually quite a bit early. 8 minutes early. So, so then yes, we can finish, I think. Thanks for watching, viewers, and let's stop.